Hello, this is exercise 1 and in this exercise we have 4 experiments. So let's see all the 4 experiments. The first experiment is to get the reverse of the number. So let's see its program. Okay, here we have taken, in this program I have taken 3 variables. The first variable is n, the second is d and the third is sum, which I have assigned a value of 0. Secondly, in the second line, I have asked for the user to enter a number, and I have stored its value in n. Then I have used a while loop. In which I have given the condition n is not equal to 0. That means it will run until n is not equal to 0. In this while loop, I have given 3 statements. The first statement says that d is equal to n modulo 10. D will store the last digit of the number, that is the input given by the user. Then sum equals to sum into 10 plus d, and finally I have terminated each digit by dividing n by 10 and I have stored it in n. So this while loop will run until n is not equal to 0. Once it's done, the reverse of the number will be stored in sum, and I have printed it out. The reverse of the number is sum. So let's check the program. Let's compile it first in the G++ compiler. G++. Okay, now let's run it. Okay, so I will enter a number 1 2 3 4. Here you can see that the output is 4321. That is the reverse of the number. Now let's go to a second program, that is to check whether a number is Armstrong or not. So let's open the code for this. Okay, in this program I have initialized the first variable n, second m, third d, and the fourth one where sum equal, I have initially assigned it to 0. In the second line, I have asked the user to enter a number and I have stored it in the variable n. I have stored the value of n in a temporary variable m, where I will check after this while loop is executed whether m is equal to sum or not. In this while loop, I have given the condition that it should run until n is greater than 0. So this will run until n will be greater than 0. Inside this while loop, I have given 3 statements. The first statement, where d is equals to n modulo 10, will store the last digit of the input given by the user. Second, in the sum I have stored sum plus d cube, which will store the sum of the cube of each digit. Finally, I have terminated each digit of the input given by the user by applying n equals to n mod 10, n divided by 10. Once this loop is completed, I have checked whether m is equal to sum or not. If it is equal, then the number is Armstrong, or else the given number is not the Armstrong. So let's check this program. Let's first compile it with the G++ compiler. That's working. Now let's see the output. Okay, let's enter a number. First we enter a random number 254. It's given the number is not Armstrong. Again we run it and we say 153, that we know is an Armstrong number. It's giving the number is an Armstrong. So a program runs correctly. Next let's see the next program. So the next program is to see whether a number is amicable or not. So let's open that file. We'll give nano. Okay, in this program I have initialized the variables a, b, and a1 which is assigned to 0, b1 which is assigned to again 0, and I, where I will be used in the loops for iterations. First I have asked the user to enter a pair of numbers which will be stored in a and b. Then I have used a for loop where I starts from 1 and goes till a by 2 and I++. In this for loop, I have used an if condition which states that if a modulo I is equal to 0, then increment a1 by I. In the second for loop condition, I've used the I from 1 to b by 2 and in this I have given the if condition. If b modulo I is equal to 0, then b1 should be incremented. After both these loops are completed, I have checked whether if a is equal to b1 and b is equals to a1. If so, it should print these are amicable, else it should print it is not amicable. So let's run this program. First, let me compile it. Okay, let's add a random number 123 and 256. It is giving it is not amicable. Now let's see for the other program. 220 and 284. Here it's showing it is amicable. As we know, these two numbers are amicable. Now in the final program, which is to check whether a program is palindrome or not. So let's open a program. Here in this program, I have declared the variable temp, which stands for temporary. I have variable n, a variable d, and a s, which is initialized to 0. Then I have asked the user to enter a number, which is stored in n. Then I have stored this value of n in a temporary variable, which I will finally try to compare and check whether it's a palindrome or not. Then I've used a while loop where in which I've given the condition n should be greater than 0. Therefore, these all three statements will run until n will be greater than 0. The first statement states that d is equals to n percentage 10. This will take out the last digit of the number given by the user as input. Second, I have stored s equals to s into 10 plus d. Finally, in the third statement, I have terminated each digit of the number given by the input by giving n equals to n divided by 10. Once this loop is finished, I have checked, given the statement as reverse of the number is, and I have checked that if s equals to temp is having the original value that the user gave. If is it equal, program prints it is a palindrome, or else it prints it is not a palindrome. So let's check this output. First we compile it. Okay, now let's run it. It's asked for a number. First we enter a random numbers 56. So it gives the reverse of the number is 652. It is not a palindrome. Now once again I run this program and I enter the number 121. Since it's a palindrome, it's printing it is a palindrome. So these were the 4 programs. Thank you.